Now we will start object orientation. Now one important thing is, for this section you should watch all the videos in the same order. Don't skip any video because the topics are linked with one another. And my explanation of a topic may be related to the previous topic covered. So don't skip anything and watch them thoroughly. Then I can help you in giving you complete picture or the clear picture of object orientation. So let us start with object orientation. See, it's a strategy or a style of developing application, developing a software. It's a methodology. Like other methodologies are also there, like structured programming, procedural programming, or modular programming, or aspect-oriented programming. So there are other styles also available. And one of the well-known and famous style is object orientation. All the latest languages supports object orientation. And this object orientation is more related to designing of a software, and this deals with internal designing, not external, that is visible designing. So it's nowhere related to the user of your software. It's related to the programmers who are working for developing a software. With the help of object orientation, the application development or the programming becomes more and more systematic, and we can follow the procedures of engineering to develop a software. Like in other engineering, how any product is developed, same way a software product is developed by adopting object orientation. If I talk a little bit about other engineering, like suppose a civil engineer is constructing a building, then first of all he will make a plan, he will make a design. While making a design, he may be having many options, but he will select one of the design and finalize it. Then once it is finalized as a blueprint on paper, then he will start constructing. Same way, an electronic engineer, when he is manufacturing any device, he will come up with some design, that is circuit design of that device on paper. Once it is finalized, then he will start manufacturing the device. So on paper we make blueprints. So we are not using paper nowadays. We have many computer-aided tools. So let us just imagine on paper we are working. So same way, for developing a software, we want to do some paperwork, come up with some blueprint, and then we start developing a software. And a team of programmer can work over a single software, and the work can be distributed easily, and the work can be reused between the programmers very easily. So object orientation, it all depends on how you see the system, how you understand the system. Looking at a system and your perspective is more important. So if you understand the system perfectly and your perspective is clear, then you can develop a better system. Not just object-oriented programming, there are other programming styles also, like procedural programming, modular programming, structured programming, and aspect-oriented programming. But object-oriented programming is well-known and successful paradigm for software development. Most of the latest languages that are used for application development, they are object-oriented. Now, I am going to explain you object orientation through modular programming. The reason is, people who learn C++ will already be knowing C language. So C language supports modular or procedural programming. So based on that, I can give you the idea how object orientation is different from modular programming. Let us compare them through some examples. So first, I'll take an example of bank. If you're developing an application for a bank using modular programming, then how you see the system, how you see the working of a bank. So what will be your design? So that depends on how you understand and how you see the system. So let us see how I am looking at a system using modular programming. See, at the bank, you can open an account, and you can deposit some amount, and you can withdraw some amount, or you can check balance. You can apply for loan, so on. So these are the things that you can do at the bank. So opening an account is a function. Depositing some amount in your account is a function. Withdrawing is function. So all these are nothing but functions. So at the bank, what all you can do, each thing you can call it as a function. So if you are developing a software for a bank, it is nothing but a collection of functions. So bank application will be based on the function, and the user of your application will be utilizing these functions for performing his required task. So you will develop a software in the form of set of functions in modular programming. Now, for object orientation, I'll take some different example. See, government provide a lot of services, like one of the services, electric service and water works, water supply service and education, transport, and even government can have banks and so on. So all these are departments of a government. See, this is a department. So all these are departments. Now what you can do in this department as a user, you can apply for new connection, or you can close your connection if you want, if you have extra connections, or you can make bill payment, bill pay. Then what these are? These are functions belonging to this department. Now same way bank is also there, so same function, deposit and withdraw, all those things. So these things comes as a function of the bank. So now what is this? So for these also you may be having some functions. You may be having these functions. So what do you call to these? These we call them as objects now. So complete system for a government, a complete software for a government is a collection of set of objects, I can say now. Now each object is having its relevant functions. These are relevant functions. So related to transport, related to banking. So a complete software is collection of objects, and objects contains functions as well as data related to those functions. And here the system was collection of functions. So if you compare them now, this we are looking at very close level, and this we are looking at little far away level. So if you look the things closer, like if you go closer to the bank, then everything inside that is nothing but set of functions. So the point here is that I can tell you one thing. When computer science was introduced, the computers were used for performing some simple, very small tasks. Then later on later on people were started getting acquainted with computers, so they started using them for larger and bigger tasks. So at the time when C language or procedural languages were there, everything was not computerized in the system. Suppose any organization, any business organization was not computerized everything. They were computerizing some part of it, like accounts part of it or payroll part of it. Right? Everything was not computerized. So when the programmers were working on one particular department, then they were looking at everything as functions. But now we are developing a software at a large scale for a big organization as a complete one single software. Then you can see all the things as a set of objects. So electric related things are functions related to electric, and transport related functions are related to transport, and those are objects, and this is collection of objects. So we have increased our level of looking at a system, because earlier we were solving a small problem, now we were solving a bigger problem. That's how when this trend has started, then there was a need of some methodology that should support software development easily. So yes, object orientation is best suitable for large size systems. I'll take one more example. Let us talk about a manufacturing firm which manufactures some goods. Let us say automobile company which manufactures cars or vehicles. Then if you look at that manufacturing firm, then it may be working in the form of departments. Like one is the inventory department which will buy raw material and maintain the stock of raw material, and one is manufacturing, that is the production work that they do, and one department will be looking at sales, one department is looking at marketing, and one is about payroll, and one is for accounts and all. So there may be many departments. Now if you are developing a software only for payroll purpose or only for inventory purpose, then you may look at the system just like modular, and in that you can find the pieces like placing an order and checking the current stock, checking the reorder level. These type of things you can have set of functions in that. So you can develop the software only for the inventory system as a collection of function. But when you are developing a software for the entire organization, then you have to see the things in the form of objects. So there, the items is an object, the inventory items is an object, employee is an object, account is an object, and the product manufactured is an object. The machines that are used for production is an object. So all these things are objects. So you have to see the things in the form of objects and define their data and the functions that they are performing. So that's it, the level at which you see the system has changed. We are looking at the system at a higher level, so we can adopt object orientation. So that's it, this is the introduction for object orientation in comparison with modular programming. So that's all about object orientation. So the next video will be on principles of object orientation.